Here's the uncomfortable truth. When you send a prompt to an LLM, it does not understand your request the way you think it does.
Right. It does something stranger and more mechanical. It turns your text into tokens, fits those tokens into a limited context window, and then predicts the next token, one step at a time, until an answer appears.
So the magic trick is really a very fast guessing game?
A highly informed guessing game, yes. And if you get that flow, you suddenly understand why prompts work, why they fail, and why tiny wording changes can flip the result.
That matters, because if you are building with AI, the winner is not the person who says smartest sounding prompt. It is the person who knows what the model actually sees.
Exactly. A good mental model is this. You are not handing a mind a task. You are arranging a sequence of symbols and asking a system to continue that sequence usefully.
Let's make that concrete. I type, write a Python function that removes duplicates from a list while preserving order. What happens first?
First, your raw text gets broken into tokens. Tokens are chunks the model works with. Sometimes a token is a whole word, sometimes part of a word, punctuation, or even a space pattern. The model does not receive your prompt as one clean sentence. It receives a stream of token IDs.
So even before the model answers, my perfect English has already been chopped into pieces.
Yes, and that matters because token boundaries affect cost, speed, and sometimes behavior. The system is operating on these pieces, not on your intuitive idea of a sentence.
Then, where does the context window come in? People hear that term and act like it is mystical.
It is simpler than it sounds. The context window is the amount of text the model can look at right now. Your prompt goes into that window, along with any system instructions, chat history, tool results, pasted documents, and eventually the model's own output as it writes.
So, the window is not just my last message. It is the whole working memory for this turn.
Exactly. Think of it like a whiteboard with limited space. If the board fills up, older material may be dropped, summarized, or never included. That is why long conversations drift and why buried instructions can lose power.
That sounds like a real power shift. The best prompt may still lose if important context gets crowded out by junk.
Yes. Example, if you paste 10 pages of logs and then ask one tiny question at the end, the model may spend attention on noise instead of the line that matters. Good prompting is often good context management.
All right. Tokens go in. They sit inside the context window. Now how does the answer come out?
Token by token, the model looks at all the tokens currently in the window and estimates probabilities for what token should come next. It picks one token, appends it to the sequence, then repeats the process with the updated sequence.
Why not generate the whole paragraph at once? Humans think in chunks.
Because the model is built to continue sequences one step at a time. Each new token changes the probabilities for the next one. That is why the output can stay coherent across a sentence, fix its own direction mid-answer, or sometimes spiral into a bad path after one unlucky token.
So one token can tilt the rest of the answer. That raises the stakes fast.
It does. Imagine you ask for code, and the model starts with the token def versus import. Those two openings can lead the response down very different branches. Early tokens create momentum.
Give me a mental model a programmer can keep in their head without learning transformer diagrams.
Think autocomplete on hard mode. Not keyboard autocomplete for one word. Autocomplete for everything. Code, prose, JSON, error explanations, SQL, emails. You provide the prefix. The model keeps extending it in the most plausible direction.
That sounds almost too simple.
Simple, but useful. If your prefix says be concise, return JSON, use these fields, and here is an example, you are shaping the continuation. If your prefix is vague, conflicted, or overloaded, the continuation gets shaky.
Let's do another example. I say, return valid JSON with name and age. Then I also ask for a friendly explanation under it. What happens?
You gave the model two competing continuations. One path says strict JSON. Another path says conversational text. Since it generates token by token, it may produce valid JSON first, then keep going and break the format. The prompt was not just unclear, it encoded conflicting next token incentives.
That explains a lot of broken integrations.
Exactly. The teams that win are often the teams that reduce ambiguity. They separate instructions cleanly, control context, provide examples, and ask for outputs that align with how sequential generation works.
And the teams that lose,
They treat the model like a mind reader. They stuff in massive context, bury the important constraint, and then blame randomness when the model follows the strongest local pattern instead of the intended goal.
so when I send a prompt, I am really staging a narrow runway for the next token, then the next, then the next.
That is the right picture. Prompt becomes tokens. Tokens fill a context window. The model predicts one output token at a time. And the quality of the result depends on what was in view and which next steps your prompt made most likely.
Which means prompting is not mythical phrasing. It is sequence design under memory constraints.
Exactly. The moment you see that, you stop asking, why is the model weird, and start asking the better question, what sequence did I actually set in motion?
And that is the shift. If you understand the token stream, you stop treating AI like magic and start using it like a system.